Hello guys, welcome to my channel SwathiPharmaJnan, sharing knowledge. Today's topic is cephalosporins. For penicillins, you can check my previous video. Coming to introduction of cephalosporins, cephalosporins was isolated by Guy Newton and Edward Abraham. So they have isolated the first cephalosporin and they have named that first cephalosporin as cephalosporin C, which was isolated by Guy Newton and Edward Abraham. Cephalosporins are also beta-lactam antibiotics. They contain beta-lactam ring. This beta-lactam ring is fused with thiazine heterocyclic group. What is thiazine? It is a six-membered ring containing one nitrogen, and thia means sulfur, as means nitrogen. It is a six-membered ring containing one sulfur and nitrogen is called thiazine ring. Cephalosporins were isolated by an Italian scientist. First isolated by Guy Newton and Edward Abraham, but the real cephalosporins have been isolated by Italian scientist Giuseppe Brozzo. He is a Giuseppe Brozzo from cultures of Cephalosporium acrimonium, which is a fungus. From the cultures of Cephalosporium acrimonium, which is a fungus, he has isolated cephalosporins. Then he noticed that they are very much effective against Salmonella typhi. Salmonella typhi, which is the microorganism which will cause the typhoid fever, and it also had beta lactamase enzyme. This beta lactamase enzyme will break the beta lactam ring in penicillins, and it will start this species will start showing resistance towards the penicillins. So when the patient has started showing resistance towards the penicillins, or when the species started showing resistance towards the penicillins, then we can switch it off to cephalosporins. Coming to SAR of cephalosporins, this is the general structure of cephalosporins. This is beta lactam ring, and beta lactam ring is fused with dihydrothiazine ring. This dihydrothiazine ring contains sulfur and nitrogen at first and fifth position. At first position sulfur is present, and at second position there is a CH2 group. Next, at third position there is a carbon which contains one hydrogen atom and one alkyl group. This is R2. Next, at fourth position, one more carbon atom. Fifth position, nitrogen is present. This is sixth position, seventh position, and eighth position. At eighth position, there is a ketone group. This ketone group belongs to beta lactam ring. Beta lactam ring and dihydrothiazine ring together we can call it as CEPAM. Next, at seventh position, there is a acyl side chain which is similar like penicillins. First point is beta lactam ring is fused with dihydrothiazine ring, which is required for the antibiotic activity. The entire ring together, these two rings together, we'll call it as CEPAM. CEPHAM, CEPAM. Substitution at seventh position, this is seventh position. Substitution at seventh position of beta lactam ring will alters the spectrum of activity. Means the spectrum of activity means narrow spectrum or broad spectrum. Depending on the R group, it may alter. The spectrum of activity may alter of various cephalosporins. At third position, this is third position. At third position of dihydrothiazine ring, substitution with various groups shows pharmacokinetic properties of cephalosporin. Different substitution of various groups at R2 position will show the pharmacokinetic properties. What are the pharmacokinetic properties? Absorption, metabolism, distribution, and excretion. That properties may alter. That properties showing of pharmacokinetic properties depends on the R group which is present at third position. This is regarding SAR of cephalosporins. Coming to classification of cephalosporins, cephalosporins are classified into 5 generations. The first generation cephalosporins are cephalexin, cephradin, cephadroxil, cephalothin, cefapyrin. Second generation cephalosporins are cefuroxim, cefoxitin, cefaclor. Third generation cephalosporins are cefixim, cefpodoxim, ceftriaxone, cefoperazone. Fourth generation cephalosporins are cefepime, cefpirome, cefquinone. Fifth generation cephalosporins are ceftobiprole, ceftaroline, ceftolozane. Why this various generations of cephalosporins are available? Because when the first generation cephalosporins have started showing serious side effects or any toxic effects in the patients who have taken or long term usage, then they will do the research on this cephalosporins and they will do minor changes, or they will introduce or substitute they will substitute or replace some groups. So that will lead to another generation. When this generation cephalosporins also started showing some side effects, they have introduced third generation cephalosporins. So after first generation and second generation cephalosporins, third generation, fourth generation and fifth generation cephalosporins have given minimal side effects. So that's why these many generation of cephalosporins have been introduced in the antibiotics therapy. First generation cephalosporins are active against gram positive bacterial strains, with the succeeding generations progressively more active against gram negative bacterial strains. The first generation cephalosporins have showed best activity towards gram positive bacterial strains only. They are not showing any effectivity towards gram negative microorganisms or gram negative bacterial strains. So that's why they have introduced second generation cephalosporins, which have showed better results towards gram positive and gram negative bacterial strains. Third generation, fourth generation and fifth generation also, they have showed more activity towards gram negative bacterial strains. Fourth generation cephalosporins are called extended spectrum antibiotics. What is extended spectrum antibiotics? They have showed broad spectrum, means different types of species diseases. For various microbial diseases, we can use fourth generation cephalosporins. This is regarding introduction of cephalosporins. We'll see the structures and uses and toxicity of cephalosporins in my next video. Thank you.